Hey everyone, welcome to Hawks Tutoring. So today we're going to be doing question 11 on chapter 2a, which is your first chapter on vectors. Yes, we all excited? Well, I am. Well, not really, but I am kind of. Anyway, so let's get into the question. So, A, B, C, D, E, F is a regular hexagon with center G. So regular hexagon, you see a hexagon here. It's regular, meaning your length are all equal, so your side length are all equal, and they are parallel. So C to B and E to F is parallel, A to F and C to D are parallel. So just keep that in mind, and it's got the center G. The position vectors of A, B, and C, so these 3 points right there, A, B, and C, relative to an origin O. You look at your diagram, do you see an O? No, we don't. So you have to put O somewhere, just anywhere really. And of course, these A, B, C, those position vectors, are vector A, vector B, and vector C. So if it's bold, it means it's a vector, right? And as students, you do not bold. When you're writing your vector, you don't bold it, you put your squigglies under it, okay? So just be careful there. So to answer this question, before we actually get into the question, just put O anywhere, like your origin, just put it anywhere. You can be even up here if you want, but just put it somewhere visible, and let's start solving the question. Express OG in terms of A, B, and C. So how do you go from O to G? Let's fill in all our information first. We know that O to A is vector A, O to B is vector B, and O to C is vector C. Sorry about my drawing. I'm not doing, I'm not great at arts, but it's just maths. Just be able to draw lines. That's all you need. Okay. Vector OG. So how do you go from this point right there to that point? When you're doing vectors, if you want to go from one point to another point, you can actually add vectors together. So you can go O to A to G, or O to B, B to G, or O to C, C to G. You can even go OD to DG, but that's just wasting too much time, right? I mean, we don't even have information on OD. You can find it, but there's no point. It's too long, okay? So to go to O to G, let's use our favorite letter, O to A. Well, not really, but might as well pick one, right? O to A plus A to G. So our path here, I will draw it, will be from O to A. That's what we're going to do. O to A, and then A. Whoops. Like I said, I am not good at drawing. O and A to G. Okay? Right, how do we find O to A? Well, we already given that information. It's just vector A. But what about A to G? That's a tricky bit, right? That's probably why you came here for this video. How do you get A to G? If you look at your hexagon, when you're doing vectors, this vector right here isn't just that vector. You can actually find other equivalent vectors on your diagram. So if you have a look, B to C right here actually is the same vector as A to G because they have the same length. Remember, it's a regular hexagon, so B to C and A to G is the same length and they are parallel just from the looks of it. Very simple, okay? So same length, parallel, therefore vector BC is the same as vector AG. I can easily replace this right here with OA plus vector BC, okay? So how do you find vector OA? We know that's A. How do you find vector BC? So the trick here, guys, is, well, you can use it, there's two ways of doing it. You can either go look at the diagram, B to C would be B to O, O to C, or the simple trick is if it's from the origin, you can just go vector O to, O to the second letter minus O to the first letter. So that's the handy trick I do with vectors. It just helps saves a lot of time instead of looking at diagrams. Or you can, of course, it's pretty clear as well. So in this case, vector A is just vector A, OC vector C, and OB is vector B. And there you have it. That's how you solve for OG. Moving on to part B, we need to solve for CD, right? CD, right? How do you solve for vector CD? Very simple. Just look at your vectors again and just find, how do I go from C to D? Well, you can go from C to G and then G to D, right? So C to G plus G to D. There's so many different ways of solving for this. I just reckon this one's pretty easy. C to G, G to D. If you have a look, what is the equivalent vector of C to G? That is B to A. So B to A right here is the same as C to G. So you can write it as B to A. And what is the equivalent of G to D? That is the same as A to G, right? A to G, same as G to D. So plus AG. And of course, we already know what AG is. AG, as we've said, is BC. So that's BA plus BC. BA, use the handy trick, O to A. So that's vector A minus O to B, that's vector B, plus O to C, that's vector C, minus O to B, that's vector B. And that's it, guys. Simplify it, A plus C minus 2B, and that is how you find vector CD. Question 11. Right, so that's pretty much question 11, guys. Thanks for watching, and I'll see you next time. Catch you later.